Hi everyone. Today we're going to study closure property of rational numbers. Closure property states that if A and B are rational numbers, the result of the operation A asterisk B is also a rational number. Now let us revisit the closure property for all the operations on whole numbers. We have this table with three columns. In the first column, the operations are there. Let's begin with addition. In here we have one example, 0 plus 5. 0 and 5 are whole numbers, and the answer is 5, which is a whole number. Another example, 4 plus 7. 4 and 7 are whole numbers, and the answer is 11, which is a whole number. In general, A plus B is a whole number for any two whole numbers A and B. So we conclude that whole numbers are closed under addition. Let's go to subtraction. We have here one counterexample. 5 minus 7. 5 and 7 are whole numbers. And the answer is negative 2. But negative 2 is not a whole number. So we conclude that whole numbers are not closed under subtraction. What about multiplication? 0 times 3. 0 and 3 are whole numbers, and the answer is 0, which is also a whole number. Another example, 3 times 7. 3 and 7 are whole numbers, and the product is 21, which is a whole number. In general, if A and B are any two whole numbers, their product AB is a whole number. So we conclude that whole numbers are closed under multiplication. Then we have division. When we have two whole numbers, 5 divided by 8, and the answer is we write as fraction 5 over 8, which we know this 5 over 8 is not a whole number. Therefore, we conclude that whole numbers are not closed under division. Now let us revisit the closure property for all the operations on integers. Let's begin with addition. We have here three examples. Negative 6 plus 5 equals negative 1. Negative 6 and 5 are integers, and the answer negative 1 is also an integer. Second example, negative 7 plus negative 5 equals negative 12. Negative 7 and negative 5 are integers, and the answer is negative 12, which is also an integer. Third example, 8 plus 5 equals 13. 8 and 5 are integers, and the sum is 13, which is also an integer. So in general, we say that A plus B is an integer for any two integers, A and B. So we conclude that integers are closed under addition. Let's go to subtraction. Let's have three examples. 7 minus 5 equals 2. 7 and 5 are integers, and the answer 2 is also an integer. Second example, 5 minus 7 equals negative 2. 5 and 7 are integers, and the answer is negative 2, which is also an integer. Third example, negative 6 minus 8 equals negative 14. Negative 6 and 8 are integers, and negative 14 is also an integer. In general, for any two integers A and B, A minus B is again an integer. So we conclude that integers are closed under subtraction. Let's go to multiplication. Let's have examples. 5 times 8 equals 40. 5 and 8 are integers, and the answer 40 is an integer. Second example, negative 5 times 8 equals negative 40. Negative 5 and 8 are integers, and negative 40 is also an integer. Third example, negative 5 times negative 8. The answer is positive 40. Negative 5 and negative 8 are integers, and 40 is also an integer. In general, for any two integers, a and b, a times b is also an integer. Thus, we conclude that integers are closed under multiplication. Then let's go to division. This 5 divided by 8 equals the fraction 5 over 8, which is not an integer. Then we conclude that integers are not closed under division. Let us revisit the closure property for all the operations on rational numbers. Let's begin with addition. Let's have this example. We have negative 3 over 8, a rational number, plus another rational number, negative 4 over 5. When we solve this problem, it becomes like this. We multiply negative 3 by 5, that is negative 15. Then we write the plus sign here. Then we multiply 8 by negative 4, that is negative 32. All over, 8 times 5 is 40. We simplify the numerator as negative 47 all over 40. And we see that the answer is a rational number. In general, a plus b is a rational number for any two rational numbers, a and b. So we conclude that rational numbers are closed under addition. What about subtraction? Let us show one example. Negative 5 over 7 minus 2 over 3. When we solve this, it becomes like this. We multiply negative 5 by 3, that is negative 15. Then we write the minus sign here. Next, multiply 7 by 2, that is 14. All over, 7 times 3 is 21. When we simplify the numerator, we have now negative 29 over 21. This is also a rational number. In general, for any two rational numbers a and b, a minus b is again a rational number. Then we conclude that rational numbers are closed under subtraction. Let's go to multiplication. Let us show one example. Negative 2 over 3 times 4 over 5. The answer is, we multiply negative 2 by 4, that is negative 8, over 3 times 5 is 15. This negative 8 over 15 is a rational number. So we write, in general, for any two rational numbers a and b, a times b is also a rational number. Then we conclude that rational numbers are closed under multiplication. Then we go to division. Let us show one example. Negative 5 over 3 divided by 2 over 5. We rewrite this again into negative 5 over 3 times 5 over 2. We know that the divisor must be inverted. Then we change the division into multiplication. Then negative 5 times 5 is negative 25 over 3 times 2 is 6. And this answer is a rational number. But there is a counterexample here. Let A be any rational number. Suppose we have A divided by 0. We know that 0 is a rational number. But this A divided by 0 is not defined. In this case, we say that rational numbers are not closed under division.